Good evening everyone. Today we are going to learn about hazards in combinational logic. First, let us know the definition. When the input to a combinational circuit changes, unwanted switching transients may appear in the output. These transients occur when different paths from input to output have different propagation delays. The delays explained above results in hazards. For example, in case of inverter, when we give input as 1, we need to get output as 0. Before getting output as 0, the first for some small time delay there will be output as 1. These are called hazards. These results in hazards in combinational logic. There are three types of hazards in combinational logic. The first type is static 1 hazard. In this case, first let us read the definition. If in response to any single input change and for some combination of propagation delays, a circuit output may momentarily go to 0 when it should remain a constant 1. We say that the circuit has a static 1 hazard. In this case, we need the output to be remain as 1, but we get for some small time delay like some nanoseconds, we will get output as 0, which will be like glitch. This is called static 1 hazard. Similarly, in second case, the output may, that is static 0 hazard. Here we need the output to be remain as 0, but due to some delay in the gates, we will get the output as 1 for some nanoseconds. In this case, the output will be, there will be a glitch of 1 where we need only 0. This is called static 0 hazard. Third one is dynamic hazard. When the output is supposed to change from 0 to 1 or 1 to 0, the output may change 3 or more times. We say that the circuit has a dynamic hazard. In case of dynamic hazard, when the output change from 0 to 1, it first changes to 0 to 1 and again it changes to 1 to 0 and again it will be changing to 0 to 1. Here we will have 2 to 3 steps before getting the desired output. This is called dynamic hazards. These are the following figure shows possible output from a circuit with hazards. The first figure shows the static 1 hazard. Here we want the output to be remain as 1, but for some time delay there will be output as 0. This is called static 1 hazard. Similarly static 0 hazard, we need the output to remain as 0, but for some small interval of time the output will be 1. Say the below figure shows dynamic hazards. In this hazards, we need the first example, we need the output to change from 1 to 0, but here there are 2 steps before it changing to 0. In second example, it needs to change from 0 to 1, but there are 2 steps before changing from 0 to 1. Dynamic hazards is which we need to study in this video. First, what is dynamic hazard? Dynamic hazards occur when circuit output makes multiple transitions before it settles to final value, while logic equation asks only for one transition. As I said before, the logic equation asks only for one transition, that is 0 to 1 or 1 to 0. But due to dynamic hazards, we will get 2 steps, that is 0 to 1, 1 to 0. Again, it changes to 0 to 1. The desired output 1 comes after 2 steps. This is called dynamic hazards. The output of logic equation in dynamic hazard degenerates into y is equal to a plus a complement. Here there is a problem in the equation. Just move the bracket from bracket next to equals. That is a plus a complement multiplied by a in certain combination of other variables. This occurs in multi-level circuits having implement static 1 and or static 0 hazards. By providing covers to each one of them, dynamic hazards can be prevented. Providing covers means we need to add some extra inputs which does not change any output from outputs, but it covers the hazards. It means during the time delay, the output will be correct. These are called covers. Let us learn what is dynamic hazard with an example. The example question is, check if the circuit exhibits dynamic hazard and show how the output varies with time if dynamic hazard occurs. Consider all the gates have equal propagation delay of 10 nanoseconds. Also mention how the hazards can be prevented. In this question, we have propagation delay of 10 nanoseconds and the circuit is given. According to circuit, we have the equation as AC plus BC complement whole multiplied by C complement. In this case, let us take in case if A is equal to 1 and B is equal to 1, we get the y is equal to c plus c complement into c complement, which shows potential dynamic hazard with an implicit static 1 hazard. Here we change the input of c from 1 to 0, but we will be getting, we desire y to change from 0 to 1, but before getting 0 to y from 0 to 1 we have different steps. This occurs because of the delays in the steps before, that is y1, y2, y3, y4. Here for example, when it is y1, to get y1 we want inverter, that is c changes from 0 to 1, that is 0 will be inverted and y1 will be given. Here when c changes to 0, after 10 nanoseconds the y1 will be changed to 1, that is after during 10 nanoseconds the output is changed to 1, y1 has become 1. In same in case of y2 also, y2 is nothing but it's an AND of r of y3 and y2. y3 is nothing but AND of y1 and b, AND of y1 and b and y1 are AND, has become AND because the y1 has become 1 and y3 will become 0 1 after a 10 nanoseconds delay between y1 and y3. So the output of y3 will be delayed by 10 nanoseconds in this case. Here we have y2 and y3 OR gate for y4 to get y4. Here y4 will be delayed because of y3 has been changed to 1 by 20 nanoseconds. So the y4 will be changed to 1 by after 30 nanoseconds. Then it will change. We know that to get y as output we have to make AND of y4 and y1. y1 is nothing but it is c bar. Here y1 has changed to 1 before, many seconds before, only 10 nanoseconds only, but y4 has become 0 because of y3 and y1. It has become 1, it has become 0, due to which the y becomes 0 after at 30 nanoseconds, and again the y4 changes to 1 as the before, as y3 has become 1 after y3 has become 1 at 20 nanoseconds, y4 becomes 1 at 30 nanoseconds. As y4 becomes 1 at 30 nanoseconds, y1 has become 1 before only, so we'll get for y as 1 at 40 nanoseconds. Because of we wanted the output as 1, but we have got first it moved from 0 to 1 at 20 nanoseconds, and it became again moved to 0 at 30 nanoseconds, again y moved to 1, but we wanted only 1 as the output at the finally. This is called dynamic hazard. We have represented what is dynamic hazard with timing diagram. Let us know how to prevent the dynamic hazard. The hazard can be prevented by using an additional 2 input AND gate fed by input A and B. That is, A and B AND gate is placed and its input is given to the OR gate, which by 3 input. Because of the third input, the propagation delay between the gates is been delayed, it's covered, and it will get the desired output at desired time only. Thank you. Hope everyone gets what I have told. Thank you everyone.